All right, so now we have an idea of why we might want to do this. We can kind of write out our multiple regression. So let's keep it really general. We have y equals beta 0, beta 1, x1 plus beta 2, x2 plus beta k, xk plus this error term. So remember, I'll use a different color here to explain what all these things are. Remember, this is all the other factors besides the x's are going to be in that error term. Again, y is our dependent variable, just like before, just like in simple regression. All these betas are parameters. Those are those parameters we're interested in estimating. And then finally, these x's, so I'm writing it out, are the independent variables. Independent variables. And here we have k of them. So we're keeping it nice and general right now. And remember, this is just our error term, or the disturbance. So nothing's really changed. We just have, instead of just stopping it right here at beta 1 x1 and adding u, we just have all these other terms in there. We're allowing all these other variables to affect y as well. So a different way to write this, if we wanted to write it down in terms of the observation level, we can just put an I on everything, right? So, well, on the variables. So the dependent variable for person I equals beta 0 plus beta 1 x1i plus beta 2 x2i plus dot 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 dot. All these other, we don't know how many, we're trying to keep it general, beta k xki plus ui. So this is just I equals 1 to n. So for everyone in our sample, this is kind of the relationship, right? We're just doing it at the observation level. All right, so let's talk about our estimators. Then we can think about interpretation, kind of give some examples so we can kind of put some of this together. So we've just seen a really general example of multiple regression with k number of independent variables. Let's do a quick example though. So let's imagine we're interested in CEO salary. So with our our dependent variable, and let's make it clear that we're using the natural log so there's no confusion. So the natural log of a CEO salary, we're modeling that and trying to understand the relationship between that salary and sales, and the salary and the CEO tenure plus U. All right, so K equals 2. The lawn salary is our Y variable, our dependent variable, the variable we're trying to explain. K equals 2, we have two independent variables. So ln of sales, you can think of that, that's just the x1. So that's an independent variable. And finally, we have CEO tenure, so how long the CEO has been there at this company. This is our x2, and this is just another independent variable. And of course, this is our error term. And everything else that it's affecting CEO salary, besides sales and how long they've been at this company, is kind of entering through here. Okay, so let's erase this bottom part and we'll think about kind of what each of these betas represent, which these parameters represent, or all three of them, I guess. So let's talk about our beta 1 and beta 2 here, just in our quick example of a multiple regression. We're going to get into interpretation in a second, but let's at least give some example with a defined number of independent variables here. And so maybe I'll use green. So if we remember from chapter 2 with nonlinearities, when we have log on both sides, this beta 1's capturing an elasticity, right? The elasticity of CEO salary with respect to sales. And so if we remember the interpretation of elasticity, a 1% increase in sales causes a beta 1% increase in CEO salary. And I'm going to add this last part here, and we'll kind of more explain that when we get to the actual interpretation. I guess we're kind of almost skipping ahead here a bit in the book. In CEO salary, holding CEO tenure constant. But again, we'll talk about this in a second when we get to interpretation. And it'll be clear why we need to hold the other variable constant. And so now for beta 2, we see that this is the effect of CEO tenure on the log of salary. Remember, when we have a log over here, beta 2 times 100 is the percentage change in salary from a 1 unit change in CEO tenure. A 1 unit change, maybe it's months, maybe it's years, I just don't know how it's measured, so let's just leave it as a 1 unit change. If we were given that information, we should probably use those units. Change in CEO tenure increases CEO salary by 100 times beta 2%, holding sales constant. And again, we're going to see why we hold the other variable constant in kind of couple minutes or in the next kind of video. So here's just a really quick example of a multiple regression with more than, has more than one x, so that's why it's a multiple regression. We've kind of seen the interpretation already, and we're going to talk about that in a second, but this is kind of what's going on. So here's just an example of a multiple regression.